All right, so as I mentioned before, we're going to look for turning our 15 into our powers of 2. So let's start with 7 squared. So 7 squared, of course, that's going to be 49. 49 mod 47 is going to be equivalent to 2 mod 47. And then 7 to the 4th will be 4 mod 47. 7 to the 8th is going to be 16 mod 47. And if I square again, I would get 7 to the 16th, but that's bigger than what I wanted. So notice that 7 to the 15, that's the same as 7 to the 8 plus 4. That's 12 plus 2 is 14 plus 1. Well, we know that that's going to be equivalent to 7 to the 8th. Sorry, I'm just going to say equals 7 to the 8th times 7 to the 4th, 7 squared times 7. And from this, I know that 7 to the 8th is equivalent to 16 mod 47. So I'm going to end up with 16 times 4 times 7 squared made 2. And then I have my leftover 7 times 7 mod 47. And now that's something that I can simplify and turn into 3 mod 47. So if we think about what we did here, we rewrote our 15 using powers of 2. Well, that's the same as also thinking about 15 in binary notation. Once we had our powers of 2, we wrote it as we also simultaneously computed our equivalent mods using our powers of 2, and we put those together. So the first thing we want to do is, if we have a to the m, we want to rewrite m as a sum of powers of 2. Okay, this is also the same as thinking about binary notation. Notice that with our 15, we've got 2 to the 8th plus 2 squared plus 2 plus 1. So we could rewrite that number in binary as well to help us. The next thing we need to do is we need to calculate all of our powers of 2 mod n. So we want to do a squared mod n, a to the 4th mod n, a to the 8th mod n, and so on, up to the maximum powers of 2 that we need. And then we combine those to find the remainder. So combine and simplify. And that's our general algorithm for computing a to the m mod n, or finding the remainder of a to the m when we divide by n.